Hey, what's up? Did you see what Google announced this week? They showed two things that really changed the game for artificial intelligence. And I know what you might be thinking. Oh, here comes more hype about artificial intelligence. Every day, someone says everything has changed. But this time, it's serious. And my job here is precisely to translate all this complexity for you. In this video, I'm going to explain to you in a simple way exactly how Google is managing to make small programs think for real without just memorizing, and how another scientist program of theirs just unraveled biology mystery that took humans 10 years to solve. You'll leave here understanding why this really matters. I want to know your opinion right away. What impresses you more, or maybe worries you more, the idea of small programs learning to think for real, or a scientist program that solves in days what took us a decade? Leave your first impression in the comments. Let's get to the facts. Let's start with this first new development, which in my opinion is the most brilliant from a technical standpoint. It's work done by the folks at Google Cloud, the cloud part of Google, along with a famous university from the United States, the University of California, Los Angeles. They call this new method Supervised Reinforcement Learning. The English acronym is SRL. Just that name is already pretty weird. For those who work with programming, supervised and reinforcement are two things that don't mix. They are almost the opposite of each other. I'll explain it in a very simple way. Think about school. Supervised learning is like the teacher giving you the test, and along with it, the answer key with all the answers. You, the student, in this case, the program, just have to look at the question and the right answer millions and millions of times. The program might learn to get it right, but most of the time it just memorized the pattern. It didn't understand why that is the right answer. Now, reinforcement learning is completely different. It's more like teaching a dog to give its paw. You don't show the answer key. The program has to try to do the task. If it makes a mistake, nothing happens. If it gets it right or close to right, it gets a reward like a treat or a positive point. It keeps trying, failing, and succeeding until it discovers on its own what the best path is to get more rewards. Google's big insight with supervised reinforcement learning was to mix these two things. They give the answer key to the program, the supervised part, except the program doesn't earn points just for delivering the correct final answer. It needs to prove that it understood the path, step by step. It is rewarded the reinforcement part for each correct step it takes. It's exactly like a math test. It's no use just putting the final answer x equals 10. You have to show the entire calculation, your entire line of reasoning, so the teacher can see that you really understood the problem. But after all, why is this so important? It's because small artificial intelligence programs, they use one as an example, which has 7 billion parameters, which is a way to measure the size and complexity of the program's brain, tend to fail badly when they receive a very difficult problem. If you give them an advanced math challenge or programming logic problem, these smaller programs start to hallucinate. That's what people call it when the program invents an answer that seems super confident, looks right, but is totally wrong. The old way of teaching, just giving the answer key, actually made this worse because the program became addicted to memorizing, not learning to think. The team wanted to know, how do we make this small program learn to solve the problem instead of just imitating the solution it memorized? With this new method, supervised reinforcement learning, the program gets a kind of secret notepad. Before giving the final answer, it is forced to write in this notepad what it is thinking, what its logic is, step by step. Then, with every step it jots down, the system compares it with the teacher's answer key and gives an immediate reward. The program receives feedback all the time. The cool part is that even if the final answer is wrong, the program learns which parts of the path it got right. It learns to reason, and the results they showed were absurd. In math tests, the program scores went way up. Then they combined this method with another called reinforcement learning with verifiable rewards, and the scores exploded. They were the best scores ever recorded for an open source program of this type, meaning everyone can see how it was made. And it wasn't just with math. They tested it with computer programming. The program became almost twice as good at understanding and writing computer code. What's happening fundamentally is that this method teaches the program to decide what the next logical step is to solve a problem. It's not just trying to guess the next word like your phone's keyboard does. It's a huge difference. And best of all, it's a very efficient method. You don't need a giant, super expensive supercomputer just to keep evaluating the program and giving rewards. This is wonderful for the community of programmers who work with open source, which is when people create programs and share them with everyone for free, because those folks usually don't have access to those absurdly expensive computers, like the ones that use NVIDIA's 100 graphics cards, which cost a fortune. To summarize this first part, Google is managing to teach a small program to think with the same precision and intelligence as a giant program. It's like taking a one-car engine and making it have the power of a V8 supercar engine, just by changing the way the engine is trained. This could change everything because it proves that to have good artificial intelligence, maybe size isn't the most important thing. The important thing is smarter training. And seriously, this type of smart training that turns a 1 into a V8 is exactly what I try to do here. Take a super complicated subject like this and turn it into something easy to understand. If you think this explanation deserves all that power, go ahead and leave a like and leave the hype below. This helps YouTube a lot to understand that this content has value and encourages me to keep bringing these translated news updates to you. All right, that was the first part. But while that team was busy teaching small programs to think, Google's other elite team, DeepMind, decided that still wasn't enough. They went and built an artificial intelligence that works like a real scientist. And seriously, it's not an artificial intelligence that just helps format text or organize a spreadsheet. It's a program that proposes new ideas for research, that designs how laboratory tests should be done, and that solves real scientific mysteries. They call this system the Artificial Intelligence Co-Scientist. It's built using their newest technology, Gemini 2. But it's not a single program. Think of it as a team of various artificial intelligence programs working together like a virtual lab full of specialists. It works more or less like this. There's the generator program, which keeps having a bunch of ideas and debating with itself. Then there's the reflective program, which is the annoying one in the group. It takes the first one's ideas and keeps looking for flaws, holes, and weak points. After that comes the classifier program, which holds a kind of championship between the ideas to see which is the strongest. Then the evolutionary program takes the winning ideas and tries to mix them to create an even better idea. And on top of all that, there's a supervisor program that watches this whole process and improves the team all the time. The human scientist is still in charge. They give the mission, find the cure for X, and guide the process. But all the heavy lifting of thinking, researching thousands of articles, and connecting the dots is done by this team of programs. Let's see how good this is. They did 2 main tests. The first was to try to find new drugs for a very serious disease called hepatic fibrosis. It's a fatal disease that creates scars on the liver, and human scientists have been struggling for decades to find a cure because it's very difficult to simulate the liver in a lab. The human team gave a simple command to the artificial intelligence: research ways to regulate liver genes without needing to change the DNA. The artificial intelligence dived into thousands and thousands of scientific articles in minutes and, out of nowhere, suggested 3 types of drugs that could reverse the disease. And it even gave instructions on how the humans should run the tests. The researchers took the ideas and went to test them. They used organoids, which are basically mini livers grown in a lab. And the result 2 of the 3 drugs that the artificial intelligence suggested worked perfectly. One of these drugs, called vorinostat, is a drug that already exists. It is approved by the Food and Drug Administration, the United States Health Agency, like Anvisa here, to treat cancer. In the test with the mini livers, this drug not only stopped the disease but also helped grow healthy liver tissue again. The lead researcher of the study, a guy from Stanford University, said he was shocked. He went to check PubMed, which is the world's library of medical articles, and found over 180 zero articles on this liver disease. Do you know how many even mentioned this drug, vorinostat? 7. The artificial intelligence found this needle in a haystack instantly. Humans might have taken decades longer to make this connection. To be sure, the researcher tested 2 other drugs that he and other human scientists thought would work. Neither of them worked. The artificial intelligence's choices were better. Now, his team is already negotiating with pharmaceutical companies to begin clinical trials in people. This alone would already be huge news, but Google didn't stop. In a second study, they gave a totally different challenge, a biology mystery that had been going on for a decade involving bacteria. Researchers from another famous university, Imperial College London, spent over 10 years trying to understand how some genetic hitchhikers, the super complicated technical name is capsid-forming, phage-inducible chromosomal islands, managed to jump from one species of bacteria to another. This didn't make sense because the viruses called phages they use for transport are super selective and generally only infect one type of bacteria. After 10 years of research, the human team finally discovered the secret. They called it tail piracy. These hitchhikers build the head of the virus where the genetic material is, but they don't build the tail, which is the part that injects the material. What do? They steal the tail from other nearby viruses, even from other species. They create a hybrid virus that can infect new types of bacteria. A brilliant idea. The question was simple. Could the artificial intelligence figure this out? The researchers gave the program only the data they had before they made the discovery. The artificial intelligence analyzed everything and gave 5 ideas. The number 1 idea it gave was they can infect multiple hosts because of interactions between the head, the capsid, and the tail. It's the exact same mechanism, the tail piracy. What took humans 10 years to discover, the artificial intelligence figured out in a few days. They even tested other famous artificial intelligence programs, and none came close to this reasoning. Only the team of Gemini 2 programs managed to put the puzzle pieces together. As the researcher himself said, of course the result from the artificial intelligence still needs to be checked by a human. It's not magic, but the speed gain is an absurd thing. His lab already uses this program to help with other research. It makes you think, right? If a computer program is already solving 10-year mysteries in a few days, how long until it starts making discoveries that we can't even really understand? And that thought is mind-blowing. Seriously, if you like this complete analysis today. From the smart training that transforms artificial intelligence to the scientist that solves decade-long mysteries, do the following. Leave a like and leave the hype down below. That way you're telling me you want more videos like this, and I'll see you in the next one.